Hello friends, welcome back, and this is our 24th day coding question. So today's question is LRU cache. So we have to basically design and implement a data structure for this algorithm, which is least recently used algorithm for cache. And if you want to know more about least recently used cache, then you can just click on this link and read about what it is. Basically, we come across this algorithm in operating system. So here we have to implement just two functions, and that is get and put. So the get function is defined as it will when you call this function you will get the value of the key if the key exists in the cache, otherwise it will return -1. Similarly, put function will set or insert the value if the key is not already present. When the cache reached its capacity, it should invalidate the least recently used item before inserting a new item. So basically what we have to do here while inserting a new key value pair, we have to see if that pair already exists, or if the the data structure in which we are putting these values is completely filled. So these are the cases that we have to handle while defining this function put key comma value. And also the cache is initialized with a positive capacity, so the capacity of cache will be always greater than or equal to 1. So they are asking if you could do in big O of one time complexity both the operations. So we will see. Now here there is some one example. So they are saying the capacity of the cache is 2, and first they insert 1 1, then they insert again 2 2, so the capacity till here is full. And now they want to get the value of key 1, so that should return 1. And then they want to put a new value 3 comma 3, and already we know that the capacity is full by now. So what we have to do here is that we have to um, remove the least recently used items, which is 2, because we have used this one here. So we will evict key 2 and then insert this as most recently used item. And then again, if we want to find out 2, since it is evicted before, it will return -1 because it will not be there present inside the container. Now again we are going to put a new value 4 comma 4 new key. So what we have to do here is we will have to evict the least recently used item, which is 1, and then we will insert 4 comma 4 in its most recently used position. So now if you want to find 1, it will return -1 because it is already evicted here. And for 3, it is present inside it, so only there are uh, two different keys present this time, that is 3 comma 3 and 4 comma 4. So if we want to find out the value of 3, then it will return 3. Similarly, if we want to find out the value of 4, it will also return 4. Let's see if we can solve this. So here I have taken a vector and a map. So in this vector I am going to maintain all the keys which are present right now. So the keys will be present in a manner that the most recently used key will be present at the last of the vector, and the least recently used key will be there in the beginning of the vector, and all the keys and value pair will be present in this map. And also I have declared a variable c which will hold the capacity. So here in this function I have initialized c to be equal to capacity, and then we have to basically here uh, define these two functions, that is get and put function. So in the get function, whenever we want the value of certain key, then we will call this function and pass the parameter as key. So here we have to consider two cases, that is if the key is present and otherwise. So if the key is present, then we have to do few things, that is we have to make that key the most recently used key first, and then we will return the key because that's what we want. Otherwise, if the key is not present, then we have to return -1. So what we are doing here is that we are finding where that key is present, and since the keys are unique numbers, once we find, we just have to delete that position, and then we will insert that key at the last of the vector. So now we have to implement this put function, that is define this put function. So basically here we have to take care of these three conditions, that is if the key is already present, then we have to insert the key value pair, and we have to decide how to insert. Obviously we have to insert that any key value pair in the most recently used position, and that is at the end of the vector. And also the key is unique, so if any key is already present, then we have to remove that first. So, and the other condition is that if the size of the vector is equal to c, that means the capacity of the vector is full. So in that case also we have to remove one item which is least recently used. So now another condition is that if the vector is not full, and as well as the key is not present already. So let's see one by one. Let's understand the first one, which is if the key is already present. So here I have taken an example. So here this is capacity, and then we have to insert 1 that is key value, and then we have to insert 2. Similarly we have to get the value of 1. So in the first one, in this case, we will have a condition when the key is already present and we want to insert the same key with a new value. So like for example here, if we want to insert say 3, 4. So here first of all we inserted 1, then then we inserted 2 2. Now the size is full, and when we try to get 1, we will have to make this pair as the most recently used. So we will do one thing, we will insert this at the last. So we deleted and then we insert this at the last position. So again we are going to insert 3 3. So we will have to remove the least recently used, which is 2 2 here. So we will remove that and then insert 3 3. Now we want to get 2, that will be -1 because 2 is already removed, and then we again have to insert 3 4. So here let's say we want to insert 1 4. So here 1 is already present as a key. So what we will do is, first of all we will remove this and then we will insert the new key value pair at the most recently used position, which is the last of the vector. So this is how we have to do in the first condition, which is if the key is already present. So first of all what I am doing here is I am inserting that new key value pair. So in the map it doesn't make any difference because the value of the key is updated, but in the vector we have to delete that. So what I just is simply copied and pasted this code here. So here the same thing is happening, we are finding out where the key is and we are deleting that, and then again we are pushing it back into the vector so it goes at the most recently used position. And then the second condition is that we have to see when the size of the vector is full. So when the size of the vector is full, then we have to remove the least recently used position item, so which is at the beginning because we are maintaining a queue like data structure. So this position which is at the beginning is the least recently used item, and at the last position is the most recently used item. So we will remove the first item and then we will insert the key. So here I am declaring a pointer to the first value in the vector. So then I am erasing that key from the map as well and also from the vector, and then we are pushing back into the vector the key, and again in the map also we are updating the key value pair. So this is quite simple, and in the third case we have to simply push back the key into the vector and also into the map. So this is how I have done. There are other solutions also possible. So the complexity of my solution is basically big of 1 big of n, because at most we have to go through n iterations here to find out the presence of key in the vector. So this is a big of n solution. There are other solutions also possible. So let's see if it works. So here it's all right, and now let's submit it. so it got accepted. I hope you enjoyed the session and learned from it. Thank you.